Pick the wrong motor size, and one of two things happens. Go too small, and it runs hot, trips on overload, and dies early. Go too big, and you waste money up front, waste energy every hour it runs, and get worse control at the bottom of its range. Neither is what you want. The good news is that motorsizing is not guesswork. It comes down to a handful of numbers you can actually work out. In this video, I will show you how to size a motor properly. The load it has to drive, the speed it has to hit, the margin you leave, and the duty cycle it has to survive. Let's get the numbers right. Quick note before we dig in. This is from PLC Simulator, where you can practice motor control and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the numbers. First, what actually determines motor size? Most people reach for horsepower right away, but size is set by what the load demands. Start with torque, the turning force the load needs, in Newton meters or pound-feet. A loaded conveyor, a stiff gearbox, a pump against head, each demands a certain torque. Next, speed. How fast does the shaft need to turn, in revolutions per minute? Then the starting load. Some loads break away hard from standstill, or have heavy inertia that takes real torque to get spinning. Then duty cycle. Does it run flat out all day, or start and stop? And finally, the environment. A hot, dusty, high-altitude install derates the motor. Get those 5 together, and the size almost picks itself. Now, the core relationship, and it is the one to remember. Power equals torque times speed. Mechanical power is the load torque multiplied by how fast the shaft turns. In metric, kilowatts come from Newton meters times radians per second. In imperial, horsepower is torque in pound-feet times RPM, divided by 5,252. The point is simple. Torque and speed are not separate choices. Together, they set the power. So to size a motor, you work out the load torque first, then the required speed, then multiply. What do you get load torque? From the machine itself, pump and fan curves, conveyor pull, or manufacturer data sheet. Measure or look it up. Do not guess it. Here is the mistake that kills motors. Running them at 100% of rating all day. Do not do that. Leave headroom. A motor has a service factor, often 1.15, which is how much over its nameplate it can briefly handle. That is a safety buffer, not a place to live. Size, so normal running load sits around 75 to 85% of the rating. And watch starting torque. Many loads need far more torque to break away than to keep running. If the motor cannot produce that starting torque, it stalls before it ever gets going. Check both numbers, running torque and starting torque, against the motor's curve. Now, duty cycle. Motors are rated for how they run. S1 is continuous, running flat out indefinitely. Other ratings like S2 and S3 are short time or intermittent, start, run, stop, repeat. An intermittent duty motor can be smaller for the same peak load because it gets time to cool. Match the rating to how the machine actually works. And think about the drive. A soft starter eases inrush. A VFD lets you trade speed for torque and run the motor efficiently across a range. I cover the difference in a VFD versus soft starter video, link below. One last thing, oversizing is not free insurance. A motor loafing at 20% load runs less efficiently and with a worse power factor. Undersizing overheats and trips. Aim for the right size, not the big size. So here's how to size a motor, start to finish. Find the load torque. Find the required speed. Multiply them for power. Add margin, so you run around 80%, not 100. Check the starting torque against the load's breakaway. Match the duty cycle rating to how the machine runs. And pick a drive, soft starter or VFD, to suit. Do that, and you stop tripping overloads and stop overpaying for iron you never use. Now, go make it concrete. If you want to practice motor control hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.